Good morning, welcome to the Woodwork for Inventor webinar. My name is David. I'm going to be going through some of the slides with you first to start with. So we're going to look at first some of the design and time management issues you have with woodwork and in modelling. So you tend to see sort of maybe 40% of your time is spent on the 3D modelling process, and perhaps 60% of your time may be spent in the preparation for manufacturing, so sorting out your bill of materials and your machining and so forth. So Woodwork for Inventor brings in automation which helps reduce some of these errors and therefore speeds up the time. So you've got reduced influence of human errors, so human factors coming into it, and up to 80% fewer errors, so more automation and less errors. So I've put together some what I think are the top features of Woodwork for Inventor. So you've got grain direction and oversize, quick hardware positioning and hole generation, woodwork specific bill of materials, and automated drawings. So one other one they've got is a CNC option as well. So, excuse me, grain direction affects the size of the workpiece. If you've got the grain in one direction in a straight piece of board, that works well. Obviously, if you want the grain at a different angle on a pre-laminated or pre-veneered board, you need to look at how that affects your job. So you can apply technological oversize with Woodwork for Inventor. So the next slide hopefully demonstrates that. You're routing something out, you don't want your router coming straight into a flat board, you want a bit of board for it to give a nice smooth finish. So that's the size of your final piece, there's your oversize, and then you have your final finish size. Woodwork for Inventor has a capability built into that to allow you to calculate that and put it into your model and your bill of materials. So hardware mounting and holes. Holes should mutually coincide on both connecting elements. They're usually not equal to the hole diameter of the hardware, and any change in the model should also react in the other parts, and obviously you want them marked up on your drawing, which can take some time to do. Reference geometry is very easy to use in Woodwork for Inventor to position your hardware. You can just use work planes and then reference on the modelled components against those work planes. Excuse me. It's not just mechanical joints, you can also do wooden joints as well. So you can put in dovetails or mortise and tenon joints, and then you can actually create your own joints as well. So you're not restricted to a certain number of joints, you can actually model up your own and use them as tools effectively. So bill of materials is a really strong feature within Inventor. It enables you to effectively model maybe something like a laminated board, but model it as one part rather than all the various parts. So for instance, taking this part as an example, you've got your veneer, you've got your fill piece, and you've got your edge banding. So, excuse me, we don't have to worry about modelling up 4 different components. We can model up the one part, and that enables us to create everything we need. So we're going to carry on and look at the next slide. So bomb structure, we can put on edge banding as I mentioned before. Now this can be a representation in the model, or you can actually apply a thickness to the material. You've got the core and cover dimensions, and you can also apply workpiece oversize, and you can apply it with grain direction in mind. And again, you've also got the edge banding and technical oversize as well. So with your bill of materials, it uses a separate bill of materials to Inventor. Inventor tends to be for more mechanical, so Woodwork for Inventor have introduced their own BOM, which is specific for woodwork. So you get things that you would expect: your list of parts, dimensions and quantities of the materials for the workpiece. You get the list of purchased hardware items. Order information. You can put as much or as little information in as you wish. You can also put CNC information in, so you can put external contours of processed workpieces, external mill contours. They've got what they call the POC or mill tools. You've got drill diameters and center positions, and you can do this in accordance with grain direction, edge banding thickness, and you can also pick a base point to go from. So one of the questions that often gets asked is, how does Woodwork for Inventor work? Well, Woodwork for Inventor is an add-on to Inventor, so it's not a separate package. Inventor is your powerful tool that is used for creating the complex shapes. Woodwork for Inventor puts in the specific design, bill of materials, drawing and CNC elements that help speed up the process. So you can design any type of furniture. So we're going to go through a demonstration in a minute and look at how we're going to create some furniture. Now, one point to make clear now, I'm going to be demonstrating a skeletal design method. You don't have to follow that process. So I'm working from top down, doing multi-body solids. You can work from bottom up, creating individual parts and bring them together in an assembly. Woodwork for Inventor does not restrict the way you're working. You can take old legacy parts you may have modelled in the past and bring those into the model as well. So you can model it any way you wish. So other things to bear in mind: parts are designed in the finished state, so it speeds you up. Once you've got your model done, you can generate drawings so automatically. So you've got views of the components, grain direction indicator, you've got a hole ID automatically put in there, edges which may have edge banding or coverings get given an ID to identify them quickly. And you've got your workpiece shape and dimensions, and you've got a hole table giving the information about all the holes and their positions, and the materials legends as well. You can use some of the predefined templates which come with Woodwork for Inventor, or you can configure your own drawing templates. You can have an assembly in one view, or one sheet rather, and have your child components on separate sheets, or you could perhaps have your assembly on one view and all your parts in a different file altogether. And you've also got CNC code generation as an option. So, I wanted to cover those slides fairly quickly, but if I give you a live demonstration now, hopefully that will go through and explain, or show you rather, some of the processes. So, what I want to do first is just go through this model, how we basically create the shapes first. So this, as I said before, we're going to look at a skeletal modelling type process for this one, but you can do it in any way you wish. So I started by picking, basically creating a box. You can go through and then simply doing extrusions, add parts or remove parts off to get the rough shape we want. We can then obviously shell out our components to give us our approximate shapes. Again, we're using multi-body solids as we're doing this. Then we can start extruding and placing our components into our assembly. Using work planes and work features. Again, this is just standard Inventor functionality so far. So I'm not modelling all this for now because I'm only going to be showing you the woodwork side. So you can see that using your standard Inventor functionality, you can very quickly create a profile that represents your desk and this one's been done multi-body solids, and they've been renamed. So these are going to be the components that make up our desk. This one's going to be done using mini fixed joints, but you can use wood joints if it's made out of solid wood. So the next step in our process is taking it into the woodworking environment. So for that purpose I've got another model already set up. So we've got a specific menu in Inventor for woodwork design, and like most Inventor functionalities we tend to start at the left, working across to the right hand side, and then produce our final drawings. So what we're going to do to start with is bring in some extra components. So I haven't quite finished the modelling, so I'm going to bring in some iCopy components first. So to do that I'm just going to turn off the visibility of some components in a second. So under the Assemble tab I'm going to bring in some iCopy components. So I'm going to bring in my case. So we're going to go through and pick the points. I'm going to say the front left point is here. Go for my front right point, and then my back right point. So you can pre-configure up certain cabinets that you may use again and again, or if you create certain carcasses, you can do them in this sort of format. So I'm going to say the height on here is 630mm. Go next. So I'm just going to put a D for demo as a prefix on here and go OK. So that's our first part generated. Then I'm going to put in over this side a set of drawers as well. So again we're going to pick the points we want, so I'm going to say the front left point, and my front right point, and then my rear right point. I can then change my draw quantity, so I'm going to say over here quantity is 3, and the height is going to be 630 again. And again I'm going to put a prefix on here, demo, go OK, and we can put those parts in as well. So probably the first thing to note on these parts that we put in already is these already have a grain defined on them. The grain by default has come on in the direction of the longest edge, and that's been done within Woodwork for Inventor. So this grain pattern tying up with this edge along here. So what I'm going to do now is go back into the Woodwork design area, and start associating some grain and materials. So under the assign area on this side of the screen, I can start assigning the materials. So pick that and the menu will load up. Now we've got several options. We can choose from the different materials. There are different boards we can use. So to run through the boards very quickly, we've got solid. This refers to any solid piece of wood. We've got board, so your typical MDFs. You've got your laminated board, so a board sandwiched between two different laminates. Multi-layer boards, the different boards in between the laminates. Desktop, this tends to refer to things like your kitchen worktops. And rods, so any sort of machined long piece of wood. You've also got your veneers, edge banding and paint. Edge bandings give you a thickness, so do veneers. However, one thing to note is paint doesn't give you a thickness, but you can specify it as paint being there, and then obviously refer back to your data sheet and update this in your bill of materials afterwards. So what I'm going to do for the moment though is utilise the material picker option. If you've already got a material associated, you can go through and match it. So I want to say there's my material picker, that face there. See, it recognises it as laminated board with that finish. So it's group 1 colour and it's medium density chipboard. And I can pick this surface here and apply, and it applies the material. So I can do the same for the other edges. So I pick material, I'm going to choose this one, apply it to several components in one go. And then for the moment I'm going to close that. Now you see at the moment it's put on the grain along the top. However, what it hasn't done is put it on the side, so you can still see visually the chipboard effect on the edges. So we know for the moment, because you can see this chipboard, that there is no edge banding applied to the edges. The other thing to note as well, the grain direction has automatically been assigned to the longest edge, but we can change that. So if I go to grain, I can pick the surface, then from the drop down, align to edge, pick a different edge, hit apply, and the grain then aligns to the edge I've chosen. So we can utilise grain as we wish. Now before I go any further, I want to address this edge banding issue here. So we're going to go through and place an edge band along the edge. So if I go back to my materials, this time from the drop down I'm going to choose edge band. Then I'm going to choose finish. I've also got a couple of choices for the material thickness. One thing to note as well, you can also position your edge banding, so it's either sitting on the existing face or you can have it so it cuts into the face. So with edge banding I can pick the face and it will go around and then go apply. You see then it applies the edge band grain along the edge to match the surface. So I'm going to put a few more bits of edge banding on. So going through, you can see my edge banding is updated. Because my grain is aligned up here, I need to think about the oversize for this piece. So I'm going to apply the oversize functionality. And you've noticed this as well, I'm not actually editing the parts individually, so I'm not double clicking on the parts and taking them into the edit environment. I'm able to do this functionality all within the assembly environment. Again, it speeds up the process. So I've got my workpiece oversize functionality. If I select that, I can select it and it automatically assigns it, and you can notice that I lined up the shape with the grain direction. So that's going to meet it perfectly. However, you do want to have maybe some oversize to allow for the machining, otherwise you're going to get probably a not very nice finish around this edge. So I could say I want a 25mm oversize to allow for that. So in here, 25mm, and we can apply that all the way around. So we've now got our oversize onto that piece. I can change my grain direction again, so I can pick that work surface, and I can go reset direction, apply, and it puts it back again to the longest edge. Pick my oversize again, and this time it still keeps the technological oversize, but it just reassigns the grain direction and the oversize back in line with it. So you see it's quite fast and quite efficient at applying that in there. Next thing we're going to look at is the edge banding wizard. Now you can use this tool if you want to show the actual physical edge banding. So if I pick the edge banding wizard, so create edge band, pick all wood parts, and you can go through there and it puts in a physical representation of the edge banding into your model. The only thing I'd recommend that you don't do is put on edge banding or be aware of your edge banding when you come to put in your fixings. Because if you put in your fixings based on the edge of the component, you need to be aware whether or not your edge banding is going to be put on after you draw the holes, which is probably most likely. So I'm just going to undo that option for the moment and leave it as is. Our edge banding is still there, it's still coming to the bill of materials, it's just not giving me a physical representation. So we're going to go in and put some fixings in. You may have noticed already I've got a mini fix on the screen. Now I'm going to use this one and position it in the model. What I've done to make my life a little bit easier is I've already positioned in some work planes. I'll just turn them off. So I'm going to open my view tab. I'm just going to turn on my work planes. So using work planes is a nice easy way of positioning hardware. So what we're going to need to do, we've covered these first tools, we're now going to our joint environment. So far we can model it up, we've assigned all of our materials, assigned our edge banding, we've put on our grain direction, and we've specified our oversized materials. So now we're going the next step in the process, which is attaching all the parts together. So you can place components individually, or you can do multiple components at once to be more efficient. So if I go to the attach command, under the mode, I've got attached multiple instances of hardware. You can go to the library. Now Woodwork Inventor does come with quite a reasonable library of components. If a component isn't there that you want, you can either put one in which is very similar and then change it in your bill of materials, or if you want to, you can actually create your own fixings and joints from scratch, and it has got instructions upon how to do that. So what I'm going to do is say I want this component here. Then I need to say what's my nested board, what's my pillar board, and what's my axis. So my nested board for this one's going to be this one here. My pillar board is that one. And my axis, I can pick several axes at once. So 1, 2, and 3. Go attach. And you can see there it's placed in the fixings automatically. If I just turn off the work plane so we've got a bit more clarity. At the moment, if I turn off the visibility of this component here, you'll see there's no hole clearance at all. And all the parts are going in the same direction. So, what I'm going to do is go back into the Woodwork environment and use the match option. This enables me to flip around any components I want. So to flip around components, I could turn off the visibility like I did a second ago, but I can use the control visibility option. So if I go to components, I've got Woodwork for Inventor components enabled. I go unpick that, just go close, excuse me, and effectively turns off the enabled functionality for all the components. So I can see here that these are all aligned up in the same way. So it could be actually I want to flip this one around. So if I find this component here, go to its table and go change component, I can actually say the side needs to be right, go OK, and it changes it to the right hand side. I could then say I want to match, so there's my template and there's the component I want to match, and it flips it around nice and quickly. It saves me from having to go and find every component in the browser tree. I just pick one, go around and make them match. I want to leave the one at the end though as it is because I want the dowel to the inside. So now that I'm happy that I've got all my fixings in the right place, I can now go through and I want to use what's called the sculpt command within Woodwork, and this will cut all the holes, all of the correct sizes. So before we go any further, I'm going to turn on the visibility again and go into the sculpt command. So we're going to select our parts, pick sculpt, and close that down. If I now perhaps just open this part on its own, if we look underneath now and we zoom in, you can see it's cut the hole in both ways. It's also created the hole for the dowel, and you can see it visually, it also shows us the chipboard as well. So we've now got our fixings in place and we've got the hardware in there. If we move the hardware around, the holes will automatically move with the hardware because we've sculpted them using the Woodwork tool. So you can very quickly put in all of the hardware and all of the holes, and the holes will always be the right size because they're specified from the hardware. So you don't have to worry about putting the wrong size hole in. So for instance, screws, you generally want a small hole, and bolts generally a larger hole, and different joints you can specify whatever you want for your purposes. So the next thing we're going to look at is the bomb tool. This is excuse me, one of the most important features of Woodwork for Inventor, and it is really powerful. So Woodwork for Inventor doesn't use the bill of materials from Inventor. It has its own bill of materials. So the bill of materials is located here. We can open up the command. So initially, you can see here it shows you the components you've got. So these first components, you've got our assemblies, the parts we've manufactured, and then we've got our components in here. We can then specify information we want to be shown on our bill of materials. So we can put in the BOM header information. If I expand this a bit more, customer, company name, you fill in all these bits of information and that will come in to our Excel spreadsheet. So whether things are paid or not. All of that information is additional stuff you can add in. So I'm going to leave that empty for now. I'll just fill in. We can export to Excel once we're done. And we've also got a selection of templates. Now the templates we've got are default ones that come with Woodwork for Inventor. Now you can customize templates, so if you want to go that route I would recommend you copy a template out and customize it. So we're going to use the English one to start with. Now we've got the replace configuration. Now by default you've got the material finishes as they come in from Woodwork for Inventor. You can change them from a spreadsheet, so it comes with a list of materials, so you can obviously add to your list as well. So if you've got lots of different veneers on codes, you can add those in. So I can change any sort of veneer or edge banding to anything I have on my list. So you can set up a palette of things you generally use first in your assign area, but you may have hundreds and hundreds of veneers, so you can have a list from a spreadsheet of all your veneers and bring those in and just assign them to suit. So I'm going to go for oak. So just to select that, you can just double click on it and it goes in and updates it, and it updates the material code as well. I'm then going to look at the other components on here. So I'm going to change that ash one to something a bit different. You can also do the same thing as well for the hardware. So there's some hardware that you don't like, again you can replace your hardware with hardware from the hardware list. So there's lots of hardware already selected, so many different types again. So things like the mini fixing, you can choose different color caps to match as well. So you're not just restricted to what's shown in the model, you can override it and include anything you want. So I'm just going to put something in there which is a bit different. So it gives you your code and your name, and remember you can add to this as well. So your template is in here, so you've got your template for your furniture, hardware, and you've got another template which is for your materials. So again, just as you want to go through, you can add and generate those. You can also add in and merge an existing BOM, so you could have two pieces of furniture under one BOM which is slightly different. So you can almost have maybe two cabinets which are almost identical but have slightly different veneers. You can upload both of those into the same BOM, which then goes down to your manufacturing. So with that, I'm going to export to Excel. So I'm going to save my bill of materials. And what it's doing is generating all the information for all of the tabs. So it takes a little while to process, but this is just one of the really strong points of Woodwork for Inventor. So we're going to open it up and have a look at what it's brought in. So under your first sheet we've got our product structure. So if you remember earlier we had our header, so I just put in Greytech as the client name. We've got our materials. We've got our names for the parts we gave, code numbers. We've got our lengths, our width, our thickness and our quantities. We've got our hardware, so our fixings and so forth. That's our part data, our material. We've got our material code and our material name. And the colour, we've got a colour code and the colour name. So that's broken it down. That's our table. And we've got our drawer. So again, we've got all the parts for our drawers, the components that make those drawers up, so it structures it in the same way. We've got composite parts lists. We've got no composite parts, so it leaves it blank. Again, you've got an option for multi-layer parts list, but we haven't got any, so again, that one's blank. We've got a complete parts list, so for laminated boards. So you can see here, this gives us a list of everything. So you can see a total of 27 minifix cams and so forth. So you've also got your cutting parts list. So you've got your codes, you've got your names for the components, your material code, material name, thickness. Also tells you whether or not it's got a grain or not. So you can allow for that. Gives you the quantity, the length, the thickness, the width. Gives you the directions and so forth. Again, you've got your material summary. So you've got the amount, material, the area, your edge banding. Again, it lists the total amount of edge banding and the total purchase units. So all your purchase items. So your material summed by products as well. So laminated boards, edge banding and purchase units. So again, another way of listing the information. And anything here which you've renamed you can also have as a separate option as well. So you don't have to utilize every functionality within here, and again you can customize your bill of materials to suit. So any of the information within the model you can pull into your bill of materials, and you've got that sort of grain information, your oversize information, and all the sort of hardware which is beneficial to speed you up. So that's your bill of materials. There is more you can go into. We could also load up additional columns as well. So we can go in there and bring in more information as well. So you can really customize the bill of materials more so than you can just in plain Inventor. Because Inventor is probably more of a mechanical side, but this one is tailored just for woodwork. So the next one we're going to look at is the Autoplot command. Again, this is one of the functionalities which can really speed you up. So I'm going to choose Autoplot. So I've chosen a configuration that I've created earlier, and I'm going to use a different default template. There are many templates you can choose from. So parent to separate file, children to separate sheets and whole tables. So there are some default ones already set up and configured. However, you can go through and use your own. And again, you can choose way of saving your file too. So I'm going to start the plot. And now the plotting process takes a while because it's going through, it's interrogating every part, it's looking at its grain direction, it's going to line the views up, because you can specify in your plot if you're aligning a view to an edge of a drawing, aligning the views to the grain direction. It's calculating all of the holes that it's put in. It will do the holes from Inventor holes as well. So if you put a hole in using Inventor hole tool functionality, that will still work, as well as the holes which are generated from the fixings within Woodwork for Inventor. You can then, in your template, specify again where the assembly is, where the parts are, and the way it's going to present that information. This is just going to take a couple of minutes to go through and process. But you remember that this may take 5 minutes now, but you're saving hours of work when it comes to actually creating drawings, and it's going to create them all in the same consistent manner every single time. So what we can do now, if we go to open, we can see in here we've got all our drawings created. So we go in here, we've got the office table, which is our top level. So on the top level it's just specified it as being a drawing of just the assembly. Then, because we chose that particular file setup, we've then got all of our children created in lower levels. So there's our table. Then we go to this drawing here, which is our children from the table. So it placed each of those on separate sheets. So you can see on here, excuse me, it's put in a code against this edge, and this edge is highlighted blue. So that's our edge banding of the code. Got the red arrow here. That's defining our grain direction, and it's putting our overall dimensions for us. This component here has holes in it. So you can see here it's given it a hole code. Again, you can move the holes, the coding around a little bit to get it in a more sensible place, make it clearer. And it tells us information about the hole. So it gives us the coordinate system based on the datum. It tells us if the hole's tight. So this is just a bored hole, a little blind hole, sorry. So it doesn't go all the way through. It's a blind hole, and it gives us the diameter and the depth, the coordinate system. If you look down the bottom here, it actually tells us about the materials as well. So you can see all the materials which are listed. On this one here again, you can see it's slightly clearer, but you've again got a different edge banding, so it gives you a different edge banding code. If you want to add additional dimensions to a drawing, you can do so using the ordinary annotation tool in Inventor. So for instance, if I wanted to say, pick a radius, I can add a radius in there. So you can add information or remove it as you wish. So again, just going through, creates the information. It also does it for the sub-assembly, so for the children of the computer storage cupboard, got the same information again. So again, I produced lots of drawings very, very quickly with minimal effort. So that's all I was planning on covering today on Woodwork for Inventor. If you've got any questions, please feel free to ask. All I was going to do is finish off by showing you a couple of slides just of what can be achieved. So there are many different types of furniture you can do with Woodwork for Inventor. So you've got nice display cabinets, modern furniture in shops, and receptions in hotels. So again, you're not restricted to just using fixings. You've got joints and many different types of finishes and surfaces. So I would like to say thank you, and those are my contact details. If you've got any questions, please feel free to ask them now, or you can type them in. Well, okay, there's no questions. I'd like to say thank you very much. If you've got any questions or think about anything afterwards, please feel free to drop me an email, which is david.bartram@greytech.co.uk, and we'll get a response back to you. Alright, thank you very much.